Okay, it's go time, ladies and gentlemen. I hope you are loving and enjoying chemistry as much as I am. Now, right now, you might be getting a little bit tired of it. You're like, oh, more chemistry, Suzak. You have cat to be kidding me right now. But no, I'm not. And I know that you are loving it, okay? But that's it. Let's talk about a couple things. You're going through your project right now, and you're thinking, a Lewis dot structure. What is that? What's a Lewis dot structure? Well, let's talk about it, okay? Lewis dot structure, what it does is it shows us the number of valence, remember, valence valuable electrons, right? The ones responsible for creating bonds, making molecules and compounds, okay? So Lewis dot shows us how many valence or outer electrons. So for example, well, like, how do we know what has what? How many valence electrons are there? It's super, super cool, folks. Look at this. We have our different groups or families here, right? We have our alkali metals, our alkaline earth metals. We have our boron family, our carbon family, nitrogen family, all right, oxygen family. We have our halogens, we have our noble gases, okay? But with these, the number or group or family that it's in, group one right here, super awesome. It makes sense because it only has one valence or valuable outer electron, right? What do you think for group two here, family two? Guess what? It has two valence or outer electrons. How cool is that? Remember you watched some introductory videos to see, this periodic table is organized to a T. It's beautiful. Everything is perfect. Transition metals, they're their own little monster. They're their own little animal. So they're a little bit different. But the boron group, now it is 13. That does not mean that it has 13 valence electrons. It means that it has 3. All right? 14. Group 14 has 4 valence or valuable electrons. Okay, we just kind of draw it like this. So maybe I have my boron, put big B here. All right, big B. All right, 1, 2, 3. All right. We just draw this little structure here. This is a Lewis dot structure. So we know that boron has 3 valence or valuable electrons. Now, if it were something more, all right, if it were something more like, let's go oxygen. Oxygen is in group 16. I need some oxygen right now because I'm just so stoked. I'm like forgetting to breathe here, okay? Oxygen, group 16. So 1, 2, 3, 4. And now I just repeat, all right? 5, 6 valence or valuable outer electrons. Okay, so there we go. Now you're like, okay, all right, I got that. But what are we talking about with this Bohr diagram? What do you mean, Suzak? Bohr. Well, hey, here's how I think about it. The Bohr diagram. Bohr gives you the whole tour. You get to see the whole tour. You get to see all of the electrons that are involved, okay, or that your element has. Okay, now how well it's like, yo, Suzak, how many electrons does my element have? Well, you know what? We can a balanced or neutral. Remember that a neutral balanced atom or element has the same number of protons as it does electrons, right? Because remember, positive protons have a p positive charge. Electrons, remember, have a negative charge. So they're balanced when the same amount of pluses or positives equals the same amount of negatives, okay? So where do we find that number? Just as a little refresher, it's all in that atomic number. So here I am for aluminum. All right, aluminum has a 13 atomic number. So it has 13 protons, 13 electrons, okay? So we draw this out simply, we just want to see how many. So these Bohr diagrams we're gonna see how many shells are involved. And right now you're thinking, shells, Suzak, I'd rather be on a beach with some seashells than listening to you. No, hey. I'm glad you're here. Don't hit that exit button. I know you want to go watch something else, but don't hang strong. Okay, so what is it? So how I would draw this, there's Al, okay, for aluminum. And I'm just going to draw this electron configuration. You're going to see with this Bohr diagram. Remember Bohr? You see the whole tour. You see all of the electrons, okay? Now, I'm going to draw these shells. There's 1. There's 2. There's 3. Now, right now, you're thinking, well, Suzak, what's so special about 3? Now, they say 3 is a magic number, but it all depends, okay? It all varies here. Well, how do I know how many shells that I have? Good question, all right? Good question. It depends on the period that it's in. Now remember, easy way to remember the periods is periods go left and right, just like sentences, right? You write a sentence left to right and you end it with a period. Unless you're super excited, then it's an exclamation point. All right, but they go left to right. So what period is it in? Oh, well, hey, great question. So 1, 2, 3, 4, 5, 6, 7. Whatever period that your element is in, that's how many electron shells you are going to have. Isn't that cool? Okay. So aluminum is in the 1, 2, 3. It's in the third period. Okay, maybe you have me for third period science. Actually, I don't have a third period this year, so no one has me. All right. It's in the third period, so I'm going to have 3 shells. Each shell has a certain can only carry a certain amount of electrons. Okay, so for example, the first shell, 1, 2. It can only carry 2 electrons, right? It's a small shell. It's like it's booked. It's full. It's like a restaurant, right? Sorry, no more room here, right? You got to go somewhere else. So I'll just put X's here for the second shell can hold 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 2 electrons plus 8 electrons is 10. Okay. I need 13, right? Because aluminum's atomic number is 13. So then in my outer shell, 1, 2, 3. Uh-oh, it all goes back to what I mentioned before about the Lewis dot structure, right? Aluminum is in group or family 13. So there should be 3 outer valence electron shells, right? So, 1, 2, 3. Okay, it's so beautiful, folks. Okay, and as you keep going down, you're going to have more and more shells because there's just so many electrons. All right, and each shell can hold a different amount. So look and try and find your Bohr diagram on. See if you can find it on Google. Hopefully that makes a little bit more sense now.